Hi guys, this is 3.3 and these are your objectives. Okay, I just wanted to kind of wave and say hi, and I'm going to make myself disappear now, hopefully. Okay. Alright, so 3.3, you guys need to write down these concepts. And as you're going through the PowerPoint, go ahead and make sure you write your notes over these things. Okay. They're important for you to study for your test. A little pun for you, because I love puns. Alright, so with different atoms, basically elements are different because they contain different number of protons. If I have 4 protons, then I am beryllium. If I have 1 proton, I am hydrogen. And that really identifies what the atom is, okay? And we write that, we call that number the atomic number, okay, the number of protons. Protons actually equal electrons, okay? So protons equal electrons, okay? And yes, sorry, I'm horrible with this pen. I will get better at it though. N is neutrons, and neutrons plus protons equal your mass number. So if you have your mass number and you subtract the atomic number from it, you will get the number of protons, like it says at the bottom, okay? Charges, neutrons are neutral, protons are positive, and electrons are negative, okay? Just to give you some charges. How these look, we have 2 examples here for helium, and in one case, the atomic number, or protons, are at the top, and in the other, it's at the bottom. This is probably, at the bottom, the more common example you'll have in how to write these numbers. And then your mass number, here with the decimal point, and here without, it's just, that's rounded. Those are your mass numbers, okay? And the atomic symbol is beside them, okay? Sorry. There were practice problems that I wanted you to do down here at the bottom to practice figuring out how many protons, electrons, and neutrons those questions have, okay? Isotopes, okay? Isotopes, again, there are practice problems at the bottom I want you to do in your notes. But an isotope is an element, they all have the same protons, otherwise it would be a different element. That's what this point here is saying. But they have different numbers of neutrons, okay? So here are 3 examples of hydrogen. You've got protium, deuterium, and tritium. And it's just calculating how many things are in the nucleus. They do not count the electrons, even though you see the electrons were present each time. Protons and electrons equal the same number, okay? Neutrons can be the same, or they could be different, okay? So practice some of those. This is where the abundance of an element comes in. Okay, chlorine appears in nature as chlorine 35 and 37. And we'll talk about that hyphen notation in a second. This number afterwards is its mass number, okay? And so chlorine 35 appears 75.77% of the time, and 37 appears 24.23% of the time. So you would calculate by multiplying the abundance by the mass number of both, and sometimes there's more. Sometimes you have 4 isotopes, and then you want to add up all those masses, and that gives you your mass number, okay? And so generally it does have decimals behind it. So here you have protons, neutrons, and electrons, the mass of 1 of each of those things. And that's how they calculate the average masses of the elements, okay, the atoms. AMU is the unit, and it's derived from 1/12 of a carbon atom, okay? And this is talking about that relative abundance that we just saw on the previous slide. Try number 13 and 17. These are in your chapter reviews at the end of chapter 3. And we'll go over these in class. Okay, atomic number we've gone over. This is just writing it out again and giving you electrons. They're basically negligible. They're insignificant because they're so small in mass compared to protons and neutrons. So we do not count those in our mass numbers. And this is that hyphen notation. You write the name of the element, and then you include the mass number behind it. So you have hyphen and the mass number. And this just helps us see what specific atom we're dealing with. Okay, and there are examples down below. This just has the mass number of silver, and carbon is including its mass number and atomic number. Okay, and so this is an example. We just did hydrogen. It has 1 proton, and because protons equal electrons, it has 1 electron. So for silver, I want you guys to look up how many protons and how many electrons silver has. Okay, so these give you an example of the other side. So looking at the mass number, if I know beryllium has 4, or it is element 4, so it has 4 protons, and I'm given that it has 5 neutrons, I know that it's going to have a mass number around 9. And so then you can follow the same pattern for sodium and gold. And then here are some more examples, just breaking down. Okay, looking at magnesium 23. Magnesium has a mass number of 23. So I'm going to subtract 23 from my atomic number, which is 12, and I get 11. So I have 11 neutrons. And then because this is not an ion, we're not dealing with ions, I have 12 electrons because I have 12 protons. And this is going over again, that AMU. So moles, this is probably the more complicated part, but it's not that bad. Okay, here's the units for moles, MOL. They save you by taking off 1 letter. And it's basically just an amount for a substance. So 1 dozen equals 12. I can have a dozen elephants and I can have a dozen books, but their masses are different, right? And so those numbers, a gross is 144. So I can have a gross of gross things, or I can have a gross of students. And that means I just have 144 of those things. It's the same with a mole. 1 mole is 6.02 times 10 to the 23rd power. Sorry, there should be a little, like this should be to the power of. Which you can see here, it writes better. So there's Amadeus Avogadro, and it's just named after him. It's actually not discovered by him. But write down this number so that we can use that. And write down this white bar too, conversion factor. So if I'm going from atoms to moles, I have atoms. There's Avogadro's number of atoms in 1 mole, okay? And again, these should be to the power of 23, sorry. So 1 mole of books is 6.02 times 10 to the 23rd books, okay? 1 mole of molecules is 6.02 times 10 to the 23rd molecules. So if you have 1 mole of books and 1 mole of feathers, you have the same amount of each. But does 1 mole of books have the same mass as 1 mole of feathers? Okay, write down your answer and we'll talk about that in class. So molar mass is basically the same thing as the mass number, okay? Molar mass is how much the mass of 1 mole, okay? So it's the number usually underneath of the element. So lithium has 6.94 as its atomic mass, or mass number. That is also how many grams are in 1 mole of lithium, okay? And we'll go over that again. If you have questions, just put a star or maybe a question mark next to this in your notes. So the molar mass of calcium, it's element 20. I looked down at its mass number. It is 40.78. And so we just round that to 40.1. Sulfur. Sulfur is element 16, and it's 32.06. And so we just round it here to 0.1. And you see our units are grams per mole. Okay, remember that. So here we have our calculations. We just write these a little bit different, but it's the same thing. These are multiplied by each other, and these are our fractions. So I start with what I've been given, 3.5 moles of lithium. And the identity of lithium is helpful, so then we can go to the periodic table and we look up how many grams is 1 mole of lithium. So I write the grams over moles, cancel out moles, and I'm left with grams. And so my units, my answer should be this 24.34 grams. Here I have moles of lithium that I'm looking for, and I have 18.2 grams. And so it's the same thing. This is basically over 1. They just divide it into 4 quadrants, 4 spaces. And so I have grams, so I put grams at the bottom. I just am rotating, flip-flopping my conversion factor. And so then I end up with 2.62 grams of lithium. Sorry, moles of lithium. And then if I'm looking for atoms, I use Avogadro's number, okay? And so it's the same thing. This is over 1, and these are multiplied. Sorry, it jumped. And then I get 24.3 grams, okay? And this again, here I'm converting grams to moles. I'm just flip-flopping, okay? Instead of moles being at the bottom, moles are at the top. Oh, my computer might die soon. Last thing. So here I have, I have grams and I want to go to atoms. So I have 3 steps, grams, and then I have moles, okay? What I want you to do is go ahead and do these practice problems, and we'll go over them in class, okay? At least try them and write down the information for them. So what you're given and what you need to find, okay? All right, I will see you guys tomorrow.